Hello everyone, welcome to another video. So today we're going to do mensuration. So mensuration is a big topic with many different shapes. So I'm going to try to cover most variations except pyramids, because pyramids are a lot more advanced. And we are trying to pass here, so whether I do the standard shapes here. Okay, so let's look at mensuration. So we have this diagram. We read the question here. There's three things here: a cone, a cylinder, and a sphere. Now, a cone and a sphere have all the formulas provided in the formula list. The only thing is cylinder. So basically speaking, any volume is going to be base area times height. So the cylinder, the base will be a circle, a cylinder, right? Then so it's circle times height. So it's pi r square times height. That's the volume. So as with all volumes, it's the same, cuboid or whatever. So the exception are pointy shapes, like cone, for example. Cone will be an exception because anything with pointy, you add a 1/3 in front. So pyramid formula also got 1/3. So that's volume in general. So for surface area, again, the cone and the sphere all have standard formulas provided in the formula list, so there's no issue there. So again, it comes to cylinder. Cylinder, there's this curved surface area at the side, right? So the general concept, but this is for another video, but a curved surface area over here is, generally speaking, the perimeter of the base times the height. So you can see that the base is a circle and the perimeter is basically the circumference of the circle. So in the cylinder's case, it will be 2 pi r then times the height. So why is it like that? It's because if you open it up, the curved surface area is basically a rectangle. So this is another video altogether, but let's start with this and let's start doing. So first question is, I want curved surface area of the entire thing. So I have three things here: the curved surface area of the cone, curved surface area of the cylinder, and the surface area of the sphere. So let's do cone first. Based on the formula list given, it is pi r l. L is here, the slanted one, not 12, not 12. 12 is the height. So L. So we don't have this number. We got to find this number first. And the thing with cone is there's a right angle triangle here. Correct? So this is 5 and 12. By using Pythagoras theorem, your L is 13. So that's how you find 13 here. Pythagoras theorem. So 12 square plus 5 square is equal to L square. So you square root, you get 13. With that out of the way, let's start using the formula. So in my mind, what I'm doing is, I have three things: this. I slot the formula in terms of the structure first. So according to the formula list, is pi r l. So it's pi r l. Pi bracket. I leave it as such when I first do it. It's all blank, all the brackets are blank. Then plus the surface area of cylinder, so that will be perimeter of base, so it's 2 pi r times height. And then lastly, it is sphere. The area of surface area of a sphere is 4 pi r square, but this is half a sphere, that's why it's 2 pi r square. With all the blanks there, then I start focusing on the numbers. So pi r l. So r, the cones r, the radius is 5. The L is the slanted, which is 13. So for the cylinder, 2 pi r times h. The r of the cylinder, the radius, is 5. And the height happens to be 5 also. So this happens to be the same number. And then 4 pi r square, again, the sphere's radius is also 5. And that's it. So once I have all this, I start counting. You notice I leave the pi all untouched. So like 5 times 13 is 65. So I wrote 65 pi. Why? Because the question says in terms of pi. So I want to leave the pi in the answer. So that's why you can see that for this one, 50, I took 2 times 5 times 5. The pi, I leave it there, and so on. So after I get all these three, I add together is 165 pi. That's the answer. Okay, so same thing. Next thing, I want to volume. Volume is actually simpler. Volume is all formulas. So I have cone, cylinder, and sphere. So cone, cylinder is 1/3 pi r square h. This is given. Cylinder, as with all shapes, is base area times height. So for cylinder, the base is a circle, so it's pi r square times height. So for the sphere, the given formula is 4/3 pi r cubed, but because it's half, it's 2/3 instead. Half. So in same thing, I slot all the numbers in, I calculate, and that's the answer. So this is basically applying formulas. There's actually nothing to think about. So mensuration is actually quite simple. Let's look at another question. Okay, so in this question, so let's look at what shape do we have. We have a hemisphere, half a sphere, and then there's a cone inside here. And if you read the question, this hemisphere, you cut away the cone, so this part is actually empty. Okay, so let's look at what they want. So this is a friendlier question because they ask you many parts. So first thing is they ask for slant height of the cone, so that will be here. So as we've just now, it's Pythagoras theorem, so 10.8 square and 10.8 square. Now why is these two numbers the same? Because this is a sphere. So if this is the center, this is radius, this is also radius. So actually both numbers are 10.8 square. So you square plus together square root, you get the L. So 15.2753. No problem. So next part, now I want surface area of the container. Now remember, the cone is being cut away. So there are two parts of the surface area. Whatever is facing the air basically. So I need the outside of the sphere and the inside here, this whole round thing that's being cut off. So if you think about it, this inside that's being cut off is effectively the surface area, the curved surface area of the cone plus the outside of the sphere. Okay, so it's curved surface area of cone, which is pi RL, and the half a sphere, which is 2 pi r square. So once I have all the brackets written, the radius is 10.8, radius 10.8, the slanted length, which is 15 point something, is here. So take note that I never use 15.3. I use 15.2735. You always use the longer number here, and hence this one there's no in terms of pi, right? I just whack everything calculator, 3SF. Okay, so same thing. Next thing they ask you the volume. So they are very, very nice. They are asking you to show. So if they ask you to show, you don't know what's the answer, but when they ask you to show, you know the answer, so there's no way you're going to get wrong. So in this case, the volume is very simple. It's basically the hemisphere minus away the cone, because the cone was cut off. So hemisphere is again from 4/3 pi r cube, half of it becomes 2/3 pi r cube. Minus away the cone is over here, 1/3 pi r square h. So same thing, I slot the formula in, I slot all the numbers in, I press calculator, this number nearest cm square, what does it say? Nearest cm square here. So all the decimal is thrown away. I throw away 1, don't need to plus 1. Exactly shown. Okay, last one, they say it's made out of some metal alloy, blah blah blah. Then this the density. So every 1 cm cube is 5 gram. Okay, 1 cm cube is 5 gram. That's how you read maths. And what is the volume of this? This is 1319.167 cm cube. So 1 cm cube is 5. Now I got 1300 plus. So basically this times 5 lah. Yeah, this times 5. Easy game. And they want nearest kg. So this is a bit tricky because this is cm and this is gram. So when you times, you're getting gram, but they want kg. Very sneaky. So from this gram, I need to divide by 1000. 3 zeros becomes 6.5 something kg. And round off to nearest kg, you throw away 5, you must plus 1 is 7. So the 7 is the answer. So hope you learned something. Thank you and bye bye.